Alright guys, we are back in action. Um, Welcome to the Code with Nate channel if you're just joining us. We are just about to start work on the back end for this beautiful sales pipeline project we just created using Angular. And essentially what it is it's a way to track different users coming through a sales pipeline so that you can kind of see where a conversion failed to happen or why a conversion happened. So basically these events come in real time. So we're about to create the back end for this using Scala Play and Akka Streams. Update the description. It didn't include Akka Streams in there. So what I'm going to do is I'm going to start in the Akka Streams documentation because I haven't used Akka Streams before. I have read some documentation and I've sort of worked with it, but I haven't really used it for any completed project until now. So we are going to figure out how to do this. So these are the Akka Stream docs. I'm going to go over to probably dependency. So, okay, just looks like that. Maybe first steps. Yeah, here we go. Stream usually begins. No, this is already once you've installed everything. Okay, so these documents, or the documentation here, starts off at us already having a Scala Play app started. So we're going to have to go to Scala Play and create a new Scala Play application using Intellij. So 2.6, is that the latest version? Yeah. We're going to use the latest and greatest. Creating a new application, that's what we want. You can download a starter project. The starter projects have a lot of comments explaining how everything works and links, blah 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 blah. Cool, yeah, starter project sounds nice, huh? SBT new, or we can do this. Let's see, can we update SBT or whatever? SBT is the build tool for Scala. SBT updates. How to use SBT version. Homebrew, install SBT. Is it brew? Did we install it with Homebrew is what I want to check now. It looks like maybe. Let's see if we can upgrade it using Homebrew, because we want to use the latest version of the build tool so that we get the most up-to-date version of Play possible. Fix the lighting in here. Hopefully that helps a little bit. Alright. Yeah, looks like that's working. But first it's got to update Homebrew. Good thing we've got fast internet. Shouldn't take too long, hopefully. So let's keep an eye. Let's look at the documentation. So we're going to be able to start. It looks like all we have to do is run this command here. And that's going to start a project for us. After that, we're going to have to install Akka Streams as a dependency in our SBT build file. And then I guess to get started, so we would have an app. We would create a new app. We're going to follow this example exactly and then and take it from there. Okay, so that should be updated now. And if we take a look at SBT, SBTV does not do what we hoped it did. SBT version. Which SBT? Okay, yeah, so that should be the brew install, the homebrew install. So let's go ahead and create a new play framework Scala seed, and we got that command from the play docs here. When we clicked on creating a new application. And right here we've got our Angular server running. Alright. Setting current project to Scalify. I wonder if this is creating all the everything inside of Scalify. It's not really what we want. Yeah, I'm gonna cancel this. I'm gonna move it into its own directory. Scalify, Scalify backend. Let's not overthink it. So our directory name is going to be Scalify backend, and we're going to start the project in here. So I don't want the files being in here. We don't have Git set up yet set in Scalify. So while we're here, I guess I'm going to set Git up so that we don't lose our everything there. Because that would really suck to lose all of our work that we just did last video. Alright, yeah, so this template generates a play Scala project. Scalify backend. Organization. com.code with Nate. Play version. That's the latest and greatest. SBT version. What version did we install? We just installed the latest version of SBT, 1.1.5. Let's go to the SBT docs. I think we would want the latest version. I don't know why we wouldn't. Maybe it will tell us what the latest version is if we look hard enough. 1.1.5, yeah. 1.1.5. Scala test plus play version. I think we'll leave that default. Alright. So, okay, so yeah, our project is in a subdirectory. So let's just CPR, or actually, we're going to just change this Scalify backend directory to Scalify backend 2, and we're going to move Scalify backend to Scalify backend into this directory, and then we're going to remove the second one. And now we should have our Scalify backend project in here, and it's got everything. So we're going to open this up in Intellij so we can get started on these code examples for Scala streams. Yeah, it's too bad the lighting's not great in here. I think I'm gonna need to get a stronger light or a better camera for this setup. Because I like the background, but I don't want to look like Anonymous in my videos either. So we'll close the blind for now. Plan on getting a better camera soon. Okay, create new project. I like to open the project, and from there Intellij will usually import everything needed. So auto import's fine. Everything else we'll just leave as is. It's odd that we have Gradle here. I wonder what Gradle is set up for. We're using SBT. Although I do like Gradle as a build system better than SBT. Close. I wonder if it creates us both a Gradle and a SBT project so that, oops, that's way too big. So that we can choose. That'd be kind of cool if that Scala played seed or whatever it was called that we used to create this scaffold of a project did that for us. Let's see, what's our build SBT look like? Yeah, it looks like that's basically what it does. That's neat. Okay. So import project. We want to import it using SBT because that is the Scala way, and we're going to do it the Scala way. So it looks like if you look down here, it is kind of doing its thing, importing. Looks like it's spinning up a JVM right now. While we're waiting for this, what do you guys think about the channel and this video series in particular, where we're building this sales pipeline? Do you like the project? Do you like the format of the videos that are really casual and sort of learn as we go? Is there some video that you would prefer to see, or that you would you'd just like to see as a request? Any positive, negative feedback always helps me improve the channel. Yeah, interested to hear what you guys think. This is taking time. All right, cool. Look, things are happening here. We saw changes, so that's good. Let's take a look inside of our app directory. So we've got a home controller here, and then project that has other stuff, configuration. I don't know where we want to throw this file of ours. Let's see. So here's what we want to do. We want to add Scala, Akka Stream to Scala Play. Default streams processing library is Akka Stream. Akka Streams is an implementation of reactive streams. We want sort of Akka actors. So these actors are like long-running services, I believe, that can process data real time. Maybe we don't need streams necessarily yet. Getting started guide. Introduce. Okay. How to get started. I recommend that you start by running a simple Hello World project. Yeah, but we have a Scala Play project. Alright, fine. We will start a new Hello World project. New project. SBT. And we want the latest version of SBT. We want the latest version of Scala, which this one is not. I think, right? What did we just decide is the latest? I thought it was like 2.16 or something. 2.12.4, I guess. Really? Oh, play is 2.6. Okay. SBT, we want a new SBT project. This is Akka Hello World. So Akka is going to allow us to process our data real time. I think kind of just want to learn Akka, so that's why we're using it. I don't know if it's the best solution. We may end up replacing it for something better in the future. With something better. But for now, it's what we're going to use. So this is creating us a bare bones Hello World project here. We're going to have to go through that same process, but this should be a little quicker because it's not a big starter project like Play. And we are just going to import this. And see what we can do here. Okay. Is this done? We want to refresh the project maybe. And enable auto import. So we want to add this new dependency of Akka Stream. Browser embedded example. Oh, look at this. Tweets, map, hashtags. Convert all hashtags. Okay, so left flow sync. Interesting. But what do we do with it? So this is these like blueprints. So we can take a file writing sync, prepend the processing steps necessary to get the byte string. And of course, we're going to be using byte strings to write out to our, or as an API response to Materializer. Interesting. Oh, this is cool. Okay, before we start looking at a more involved example, we explore the streaming nature of what Akka Streams can do. Starting from the factorial source, we transform the stream by zipping it together with another stream, represented by a source that emits a number 0 to 100. The first number emitted by the factorial source is the factorial of 0. The second is the factorial of 1, and so on. We combine these two by forming strings like 3. Huh. Wild. Okay. So project all good to go. No. Yeah, that sucks. Well, this didn't work. Let's create a new Scala file. I don't know. I'm not really digging it, that Hello World project. Let's just see what happens if we create a new... Oh, man. We're having a lot of problems, I guess, with the Scala plugin or something. I wonder if we need to update our Scala plugin for this to work. Plugins. Scala. Yeah, it's a little old. What version is it on? It's on 2007-13. Everything's going so slow right now. SBT, what's going on here? Do we have an SBT shell for this project? as you can see, our project's not really vibing with Intellij very well. Not a valid key, idea shell. So to get this project to work, I guess we're gonna have to do some work, unfortunately. Not a valid key. Hello, does this issue? There is an idea.sbt file. I even removed it and restarted. I downloaded my project SBT version. Yeah, okay, so maybe we just need to go down a version of SBT. How do we do that? SBT. Of course, I don't know how to do that. Custom. Let's so maybe this version of SBT is just too new for Intellij to handle. Maybe we can download the latest version of Intellij and that would fix things. Check for updates. What version are we on? We're on version... Oh yeah, look at that. Current version is 2.5, we have 2.7. I guess we'll update our Intellij so that things work. So while that is downloading, hopefully that'll help us out a little bit. I think we will downgrade our version, maybe of an SBT. Nah, it shouldn't be necessary. If we have the latest version of Intellij. Okay, so the new Intellij is downloaded. So sometimes things like this happen with these complicated build systems, especially interacting with your IDEs, and you just kind of have to scrub through updating things, changing versions, Googling and seeing why a certain error is coming up, or really looking at the stack trace. And it just kind of happens. It's too bad. It happens with Java too. I don't ever have things like this happen to me with Node or PHP. Yeah. Gets annoying. It's just the way these big JVM based applications are built, unfortunately. Yeah, I want Darkula. No. 2018-01. Oh wow, yeah, I was on 2017 before, so I forgot what year it was. So hopefully this helps. We'll see if it does. Oh yeah, see, look, we need to update our plugins. It looks better, this IDE, a little bit. Sure, whatever. Everything. So now that our Scala plugin's updating, hopefully we'll see some progress. So yeah, so the format of these tutorial of these videos is, this is how I really work. Today specifically, this is me working on something I don't know. Usually this would be like me well, we are coding a project for fun. So this is how it's done. I don't know how this stuff works. I'm learning as we go. I mean, I sort of know how it should work, but we're using this new library that we never used. My IDE is out of date, so I'm having to update it. This is stuff that happens in real life, so I hope you guys enjoy this. If you don't, there are more structured videos on the channel that I recommend you watch, or if you have a specific problem, you can look up that problem in the channel. And if a video doesn't already exist to solve that problem, you can shoot me a message in the comments, and we can work it out. We can work out a new video. Okay, why in the world? This is interesting. There's 2 Scala plugins. However, this one says 2017. I don't think we want that one. I think we want the 2018 plugin. Where is it? Man, the tooling is just... it's a little weird. Did we do it? Is it installed or what? Maybe we'll restart Intellij. Don't see my plugin there, but it looked like it had 2 conflicting versions of the Scala plugin. Oh man, it's early, 6:22. Thanks. Come on. Alright, so as of now, this isn't all red. Oh, SBT. Here we go. Okay, so we have our SBT window. So let's see now if this is working for us. Looks like they've updated the style of the Intellij a little bit. It looks nice. Looks great. SBT changed its logo. Also, it used to be... I don't even know how to describe it, but it wasn't this hexagon here. Takes forever to index these things. I think it's almost time for a new computer. This one's 5 years old. Still chugging. Served me pretty well over the years. So it looks like our Hello World project might pull through for us. So we're going to follow this quick start guide and learn what the heck is going on with Scala streams. Oh, come on. Dump project structure from SBT. Don't fail me now. Come on. Oh, hey, look. This is looking better. It is. I think we might be okay. So we're going to create a new Scala class, and it's actually going to be an object called Hello Scala Streams. And it's going to extend app, which is a Scala trait that defines an interface for an executable Scala file, essentially. That is what Scala Streams wants us to do. Oh no, where did our stream quick start? Is this the one? Nope. Where did that go? Quick start guide. That's the one we want. So we need to add this dependency here once everything stops. There we go. Cool. We're good. Extends app and Scala.app. And I think we just start posting our code in here. So we could do print line hi. And I believe if we run this, we're going to see hi. die printed out on our console. So, oh man, I really hope this works. It took us a while to get our project started this time, and I think what it eventually came down to was us not having the most up-to-date version of Intellij, because we did update SBT, we updated, is that it? Yeah, we updated SBT, and that didn't jive well with our last version of Intellij, but it looks like it's working just fine with this latest version of Intellij, so I recommend updating everything when you're working on things. Okay, we already have Scala streams installed, or Akka Streams. So let's follow this tutorial then. So we're going to go ahead and import these imports that they recommend here to follow this getting started guide. Yeah, we already have done this. Now we'll start with a rather simple source. So a source is a source. You can think of it as an entity that emits a series of data. So this source is going to emit 1 to 100. It's pretty weird, this whole source and sync thing. Materializer, where do we get the materializer? Interesting. Complete the source with a consumer function. We're going to run this, and I think it's not going to work. You know what? I think we should not found value materializer. What happens if we run it without a materializer? Is it going to find that implicitly? Maybe. It's almost surely an implicit. Yes, it is an implicit argument. I think we're going to drop into the shell, the Scala shell, but I don't see the Scala console here. I used to be able to drop into the IDE's instance of SBT. I don't know where it is anymore though. SBT shell, it's down here hanging out. And to run, let's see, run an app Scala SBT play. To run the current application, there's a way to run an app, and one of these objects that extends app from the SBT shell. And man, it just takes so long. And it should be faster because it does a lot of the work up front, so that on every single run we don't have to do all of this stuff. Alright, are we good here? So I need to run help because I don't remember what command we need to use. About tasks. SBT shell run app. Tasks and commands. What happens if we just type run? Oh, it was run main too. Run main is the command that we were looking for. So now when we run this run command, it only has to compile this one source. It doesn't have to do all that work. And then it's going to execute this block of code. Yeah, cool. So it could not find an implicit value for Akka Stream Materializer. So that is obviously an issue. Doesn't tell us. Okay, so we have to create this materializer here, and that's going to be passed implicitly to this. I don't love implicits, so I'm going to explicitly, I guess, pass this materializer in here, although you would not have to. You could just use an implicit val, and this probably takes an implicit context. Now we'll do it the way the tutorial says to do it. Actually, I am going to add the type annotation so our IDE doesn't get mad at us, and of course that's a weird way to spell it. It's not a real word. So let's go down to our shell again and run our project. Already done compiling, and it was nice and fast. So see, it's now we don't have to do all that work. We can iterate a lot faster now that this shell's open here. So we can see that we printed out 1 through 100, just like we expected, because we had a source of integer, and we printed out each one. So. And of course this could be simplified, I think, but maybe not in the latest version of Scala or whatever. It should be. Oh, and this never completed. It looks like we've got a long-running process here somehow as a result of one of these. So now it's probably going to tell us how we close out. Yeah, so you can see. Okay, this is cool. Okay, so let's go back to our project here. So now we create our source, and val done is equal to whatever this returns or evaluates to. It's a future of done. So once this source is done printing each and every integer in that list of 1 to 100, when that future completes, we want to terminate the system. But now we're going to have to restart the SBT shell because we forgot to do this step. What else do we have here? So we're going to keep running down the docs. Factorials. Interesting. Run with source scan. I don't know what scan is. First, we use the scan combinator to run a computation over the whole stream, starting with the number 1. Okay, cool. I think we're just about ready to move on now that we've kind of got this project working. We are going to be receiving things. How does this work? I think the deal is that we create a source from live streaming data somehow. Because that sources can be reused like blueprints. Running is nice and fast, and it should close out. Okay, we need to import an execution context. The compile's pretty quick now. and it ran and it closed out our job. Cool. So now we have a working framework for dealing with Akka Streams. Time-based processing, reactive tweets. What is this? Because we're going to be using the reactive programming model to process data in real time. Typical use case for stream processing is consuming a live stream of data that we want to extract or aggregate some other data from, and that is what we're doing. In this example, we'll consider consuming a stream of tweets and extracting information concerning Akka from them. We will also consider the problem inherent to all non-blocking streaming solutions. What if the subscriber is too slow to consume the live stream of data? Usually you would use that would be backpressure that you would have to handle. So traditionally the solution is often to buffer the elements, but this can and usually will cause eventual buffer overflows and instability of such systems. Instead, Akka Streams depend on internal backpressure signals that allow to control what should happen in such scenarios. So here's the data model we'll be working through, the quick start examples. So we've got an author, a hashtag tweet, and this Akka tag is a hashtag Akka. Interesting. Transforming, consuming simple streams. So we start this actor system and actor materializer, which we have to do to use Akka. Let's assume we have a stream of tweets readily available. If Akka stream is in Akka this is expressed as source tweet. Streams always start flowing from a source, then continue through flow elements or more advanced graph elements to finally be consumed by a sink. In, out. Okay. Because ins don't have out. Okay. Ignore the type parameters M1, M2, M3 for now. They're not relevant to the types of elements produced consumed by these classes. They are materializer types, which we will talk about below. The operation should look familiar to anyone who has used Scala collections library. However, they operate on streams and not collections of data, which is a very important distinction, as some operations only make sense in streaming and vice versa. Okay. So authors equals tweets filters. Filter by hashtags that contain Akka. So we're only looking for tweets that contain Akka, and we want to map those to the author. So that would be the username probably, and then we would print out the usernames of those authors. Flattening sequence and streams. So in the previous section we were working on one-one relationships of elements, which is the most common case. But sometimes we might want to map from one element to a number of elements and receive a flattened stream. Similarly, like FlatMap works on Scala collections, in order to get a flattened stream of hashtags, our stream of tweets, we can use the map concat combinator. The name FlatMap was consciously avoided due to its proximity with four comprehensions and monadic composition. Requires a supplied function to return an iterable, whereas FlatMap would have to operate on streams all the way through. Okay, interesting. Now let's say we want to persist all hashtags as well as author names from this one live stream. For example, we'd like to write all author handles into one file and all hashtags into another file on disk. Okay. Oh, that's interesting. Let's read that again. And all hashtags into another file on disk. For example, we like to write all author handles into one file. Okay, that's cool. This means we have to split the source stream into two streams, which will handle the writing to these different files. Elements that can be used to form such fan-out and fan-in structures are referred to as junctions in Akka Streams. One of these that we will be using is the example. In this example, it's called broadcast, and it simply emits elements from its input port to all of its output ports. That's cool. Akka Streams intentionally separates the linear stream structures from nonlinear, branching one's graphs in order to offer the most convenient API for both of these cases. Graphs can express arbitrarily complex stream setups at the expense of not reading as familiarly as collection transformations. Right. Okay. So runnable graph from graph DSL create implicit B, and B is our broadcast, I think. So we import the implicits. B add broadcast tweet 2. So I think that is broadcast. We're going to broadcast the tweets, and we're going to split it into 2 streams. I don't know what this one does. Okay, that probably feeds tweets into this, to the in pipe of this junction in Akka Streams. Yes, and then out into 2 different flows, because we have sync flow and we're reading about this source as our 3 different types of whatever they're called in Akka Streams. Okay, so closed shape and then G run. So we're gonna see now. Oh, okay, cool. Yeah, so they go into our syncs. So we already have this Twitter. We already have tweets, and they are getting broadcast, or that stream is getting split into 2 different streams, and eventually, or being piped into this write authors and write hashtags syncs. Cool. As you can see, inside GraphDSL we use an implicit graph builder. Okay, that's what B is, the graph builder, to mutably construct the graph using the edge operator, also referred to as connector or via or to. The operator is provided implicitly by importing GraphDSL implicits. Cool. Returns a graph, in this example, a graph closed shape not used, or closed shape means that it's fully connected graph or closed. There are no unconnected inputs or outputs. Since it is closed, it is possible to transform the graph into a runnable graph using runnable graph from graph. The runnable graph can then be run to materialize a stream out of it. Weird. Both graph and runnable graph are immutable, thread safe, and freely shareable. Okay. One of several other shapes. Yeah. Backpressure in action. One of the main advantages of Akka Streams is that they always propagate backpressure information from stream syncs to their sources. It is not an optional feature, and it is enabled at all times. To learn more about the backpressure protocol used by Akka Streams and other reactive streams compatible implementations, read Backpressure Explained, and that is a good source of information there. You might want to read that. A typical problem applications like this often face is that they are unable to process incoming data fast enough. So with this, okay, for example, if we were interested in the most recent tweets with a buffer of 10 elements, this can be expressed using a buffer element. Buffer element takes an explicit and required overflow strategy, which defines how the buffer should react when it receives another element while it is full. Strategies provided include dropping the oldest element, dropping the entire buffer, signaling errors, etc. Be sure to pick and choose a strategy that fits your use case best. That's cool. Sometimes we may be interested in some value that can be obtained from the materialized processing pipeline. For example, we want to know how many tweets we have processed. That's cool. Well, this question is not as obvious to give an answer to in the case of an infinite stream of tweets. One way to answer the question in a streaming setting would be to create a stream of counts described as up until now we processed n tweets. But in general, it is possible to deal with finite streams and come up with a nice result as a total count of elements. First, let's write such an element counter using sync fold and see how the types look. So we've got a count, flow of tweet map. Okay. For tweets via count to materializer sum sync Okay, so we're mapping tweets into this count, which just maps a tweet to 1, and then the sum sync folds 1 plus 1, or the count, which would be 0, and then plus 1 for each count item emitted here. Cool, that's nifty. Total tweets processed. Cool. So first we prepare, So now we have tweets in minutes from now. All right. I think we kind of get how to use Akka Streams now. Now we need to figure out how we get a stream of this data, I guess. So we would be receiving sort of events from webhooks, I would think. So let's take a look at the first step in our pipeline, our sales pipeline that we created. And it's placing an ad on Google, Facebook ads. So let's see if they have webhooks. Google webhooks. Join Google AdWords and webhooks in a central warehouse. Let's see. Webhooks. This is for Slack. Posting data. Let's do a simpler one for now. This step in our sales pipeline looks kind of complicated. Prospect sees the ad. Prospect clicks on ad. So definitely at the time that a prospect is taken to a landing page, we should be able to get this data. So it would be from like a server. So we would have a landing page, a very simple page, and we'll build this out really quick using Node or whatever. And at that time, we want to broadcast the event to our Akka Stream processor here, which is going to handle that and create an event that represents this step in the pipeline here. So let's create really quick a new project. We'll create a new node project. So we're going to go make dir Sellify landing page. And we're going to go in there and run npm. First, we're going to use nvm use 9. nvm, how do I list? Whatever. npm init dot package name. We don't have time for all this stuff for such a simple project. Let's go ahead and open our Stellify landing page project here, and we are going to npm install save express, and we're also going to need some kind of HTTP client so that we can send our data to our backend. That's this is the Akka Stream project that we just made. Let's see. I want to find an HTTP client. I want the most popular, sort by popularity, request. Okay, promise-based HTTP client. I like promises. Does this table of contents? Streaming and callback interfaces natively. If you like to request the return of promises, so you can use an alternative interface wrapper for request. These wrappers can be useful if you prefer to work with promises, or if you'd like to use async await in ES 2016. Several alternative interfaces. So I don't know if we want Bluebird, probably native promises. That is what we're going to use. So we want request and request promises native. Just going to use real JavaScript promises. The finally method's not available. That's okay. We'll be all right. We want to use the native. So it's installing now. Oops, don't need you. So let's just go ahead and create our index page while those are installing. Index.js, and this is just going to serve. So we need var express equals require x. No, it's not dot slash express. It's just express. Let's go look up how to use express really quick. Express node. It's something dot listen. Getting started. I want the hello world, I guess. Hello world looks like this. We'll just copy this. And I want to see. Let's create a basic HTML file using template engines, static files. To use multiple static asset directories, call it multiple times. So we want to set up a public directory for our landing page, and we want a new file called index.html, and this is going to be welcome to Gadget X's shop, and then we're just going to have a button here by Gadget X. And now let's see here. So Let's see what happens when we run this. I want to go to localhost 3000 here. And it looks like we've got this. We've got our hello world. And we don't really want hello world. We want our landing page. Where did that go? Now you can load the files that are in the public directory. And we have a file there, index.html. But it says we cannot get that. App use, the function signature is root. Maybe we need / in front of our. Okay. It's odd. Served. We're in public. What happens if we go to static here? Nope. Alright. Is this the app that we're working with here? It is. So for whatever reason, these static files are not serving. Maybe the paths don't work too well. App use static. Let's see what happens here. Path is not defined. Yeah, this just isn't working, is it? App use. I want that function, but trying to get a working landing page here, but okay, express static files not working. What's going on here? Change your static handler to this. Oh, where is our index? Oh, index is in the wrong directory, that's why. Huh. Somehow that got stuck in our node modules and we want it in the root directory. That's probably gonna fix it for us here. Hello world. I mean, it's better, but it's not what we wanted. We want public / express.static public. Let's go back to our tutorial here. And it's just not working. Public CSS / public / CSS / style.css, but why? Yeah, this isn't working so well. not. There we go, we found GadgetX's shop. Okay, our landing page is up. I want a line break here. Alright, cool, so now we can buy GadgetX. Anyways, at the time that this file is served, we want to send a message to our Akka Streams project that we just created. And then also at the time of buy. We could start with buy, I guess. Let's start with buy. That's the really easy one. So on click, we want to send a request to our landing page backend. Let's see here. Script. So we want function by GadgetX. I think that takes an event. Throw a debugger in there. I don't know, let's see what happens. Restart that. Let's open up our debugger. So E is undefined, I guess. So I think maybe we want that to be our setup here, but I might be wrong still. How do you HL on click? How do we handle that event? Let's see, my function. Whatever, we don't need the event, do we? Not for this purpose. We also need to install JavaScript front-end HTTP client. I need some kind of simple how do we use it? I don't want to. We can just use something simple here, I guess. We don't care. This is just an example project, so we want to keep this as simple as possible. We just want to be able to fire off an event to our backend. So right now we want to send this to localhost 3000/by gadget. It would be a post, most likely false for synchronous request. We don't even care about that though. We don't need to send anything. So let's go create this endpoint in our server. And console.info buying gadget X. Let's see how that works. Look at that. Oh, did we forget to add the open close params? Yes. Oh no. Yeah, there we go. Cross origin requests are only supported for the protocol schemas, but this is not cross origin. localhost 3001 404 not found. Okay. Oh, because that's a get. We needed to create a post endpoint. Okay, so yeah, so now we can buy GadgetX, res.send purchased. Alright, so now we have essentially a landing page set up. At this point, we are going to, I'm going to pause this and start a new video. I'm not sure today or tomorrow, of us sending this data now to our Akka Streams app that we just created. So thanks for watching, guys. As always, leave comments. I love to hear feedback about what's going on. If you liked the tutorial, if you've got some suggestions on ways that this could be made better. I know this was sort of a long rambling one, where we went over a lot of content and slowly, because a lot of this was stuff that I wasn't super familiar with. So thanks again for watching, guys, and have a great day.